Next is the concept of image. Alright, what is that? Already you know, everybody knows what is image. What is image? When light rays from a point object comes out and after suffering refraction or reflection meet at a point or appear to meet at a point, then the second point is known as the image of the first point. Alright, so here depending on the cases that whether the rays are actually meeting or appear to meet, everybody knows that we can classify the image mainly into two categories, real image and virtual image. So what is a real image? When the rays after reflection or refraction actually meet at a point. You see, look at the diagram, they actually meet at a point. Then the second point, this O dash, is the real image of the first point. And when it is virtual image, when the rays after reflection, in this case reflection taking place, after reflection or diffraction appear to meet. Just look at the diagram. If you extend the reflected rays, then they appear to meet at O dash. Alright. So, in this case, the rays appear to meet at a point, then the second point is known as the virtual image of the first point. Alright. So, you must note down the differences between real image and virtual image, just like the real classes. I am dictating it, you just note it down, and already you know, everybody knows. So, first point of difference for real image and virtual image, what is that? In real image, you write it down. Real image is formed when light rays after refraction actually meet at a point. I repeat, real image is formed when light rays after diffraction actually meet at a point. Then write down for virtual image. Virtual image is formed when light rays after diffraction appear to meet at a point. Alright, virtual image is formed when light rays after diffraction actually meet at a point. Then what is the second point of difference? Everybody knows real image is always inverted with respect to the object. Alright, real image is always inverted with respect to the object. Then corresponding point for virtual image is erect with respect to the object. Virtual image is erect with respect to the object. Then third point of difference, real image can be obtained on a screen. What is the third point of difference? Real image can be obtained on a screen and virtual image cannot be obtained on a screen. Virtual image cannot be obtained on a... The next is image formation by a convex lens. Now, you know that if you want to draw a ray diagram showing image formation, then at least we need two rays. Alright? Now, what are the rays we take? We take one ray which is passing through the optical center. Alright, how it will move after diffraction without any deviation. You may take a ray which is parallel to the principal axis. Then after diffraction, it will pass through the focus of the lens. Alright, or you may take this way that if a ray passing through the focus, then after diffraction, it will become parallel to the principal axis. Alright, so out of these three rays, any two rays, we generally consider, these diagrams you don't have to draw. Out of these three rays, any two rays we generally take to draw the ray diagram. Alright. Next is image formation by a convex lens. First case, object is at infinity. Alright. So, when the object is at infinity, then remember that incident rays will be parallel to each other. Alright. Now, when the incident rays are parallel to each other, then it may happen the rays are parallel to the principal axis of the lens. Alright. In that case, what will happen? After diffraction, the rays will converge at a point. What is the name of that point? Focus. I hope you can remember. So you see the rays will converge at a point and image will be formed at the focus. Alright. So what is the position of image? This everybody knows. POI, position of image. Position of image is at the focus. So as I have named focus as F, so you can write at F. Clear? Now, what is the nature of image? You see, the ray is actually meeting at a point. So it is real image, and when if you consider the object at infinity, it is a very big in size. But what is the size of the image? It is the point. Means it is highly diminished. So what is the nature of the image? As it is a point image, so inverted does not matter. So just write down real and highly diminished. Alright? But you see here, when the rays are coming from infinity, they are parallel to each other. Then the rays may not be parallel to the principal axis. In that case, how to draw the diagram? I am just showing it, you strictly follow. So suppose first you draw the lens, locate the optical center properly here. The lens I have drawn, the upper side, lower side may not be equal, but as you are using the ruled page, in your case it should be equal. Please follow that instruction. Alright, now how to draw the diagram? Suppose you are considering that you take a ray which is passing through the optical center first. Alright, then what you will do? Then you locate focus on both the sides. Just locate 2 points on both the side at a distance of 2 inch or 2 centimeter. Alright, here I have taken. So then you take a ray which is passing through the focus and which is parallel to the line passing through the optical center. Then you see, after refraction, what will happen? It will become parallel to the principal axis. Is that clear? Then you see, from this point, if you drop a perpendicular, then this is the focus and this is the image. AF is the image. Alright. So, what is the position of the image? You will write down at the focal plane. Already I have discussed in the earlier classes also. What is the focal plane? A perpendicular plane. A plane at the focus which is perpendicular to the principal axis is known as the focal plane. Thus consider my hand at the focus and how I have set my palm perpendicular to the principal axis. So my palm is the focal plane. Alright. So where the image is produced, you see it is on my palm, means it is on the focal plane. So what is the position of the image? At the focal plane. And what is the nature of the image? Here also the ray is actually meeting at a point. So definitely it will be a real image, but do not write highly diminished because it is not a point. So you write it down as real and diminished. So when the rays are not parallel to the principal axis, then position of image is at the focal plane and nature of image is real and diminished. Next is object is beyond 2F. Alright. So here you see, you will first draw the lens, then first you will draw the principal axis, then you will draw the lens, then what you will do? Mark the optical center, then on the both side you take the distance CF as I have marked it at a distance of 3 centimeter. I hope you have understood what I have said. From the point C at a distance 3 centimeter mark a point, then at a distance 6 centimeter mark another point. Do it on the left side and right side. I repeat, from the optical center on both the side mark 2 points at a distance 3 centimeter and 6 centimeter. Alright, so you see in this particular case I have taken focal length as 3 centimeter. So twice F means how much? 6 centimeter. So at a distance of 6 centimeter from the point C you have to mark 2F. Clear? Means what I mean to say, this distance they should be equal. Alright, I hope it is clear to everyone. For next 5 diagrams you have to do this. Alright, so here what is given? Object is beyond 2F. So you have taken the object here beyond 2F. Alright, how to take the object? Take the object perpendicular to the principal axis. Alright, then how to draw the diagram? First, from the point A, you take a ray parallel to the principal axis. Alright, then after refraction, it will pass through the focus. Take a ray passing through the, take a ray parallel to the principal axis and then after refraction it will pass through the focus. Then you take another ray passing through the optical center, means join A and C. So this ray will move undeviated. So you just extend it straight and put the arrows like this. So you see the two rays coming out from the point A meeting at this point. So name it as A dash. Then from the point A dash, you drop a perpendicular solid line because it is a real object, real image on the principal axis, name it as B dash. So A dash B dash is the image of the object AB. Alright. So what is the position of the image? Look at the diagram. Where is the image? Between F and 2F. So write it down. It is between, what is the position of the image? Between F and 2F. Be careful here. Big F I have written. Alright. It is F and 2F. Then what is the nature of the image? It is real, inverted and diminished. Look at the size of the image. Size of the image is smaller than that of the object. So it is real, inverted and diminished. Alright. So when an object is kept beyond 2F, where the image is produced, it is between F and 2F and the nature is real, inverted and diminished. Next is object is at 2F. So again you draw the lens. First you draw the principal axis, draw the vertical line, draw the lens, mark the optical center. Then on both sides, as you have done in the earlier case, mark 2 points at 3 cm and 6 cm distance. Alright, and name them as CF 2F, CF 2F. Alright. So here, where is the object? At 2F. So you see where I have drawn the object AB at 2F. Then how to draw the diagram? In the same manner, from the point A, you draw a line parallel to the principal axis. After diffraction passing through focus, then you take a ray passing through the optical center, it is moving undeviated. Both the rays are meeting at the point A dash. From A dash, you drop a perpendicular. Here you will observe that the perpendicular will fall at 2F only. Alright, means what is the position of image? Position of image is at 2F. And what is the nature of image? It is real and inverted, and here I cannot measure it, I cannot show you, but when you draw the diagram, you will see that if your object is of 2 line length, the image is also coming of 2 line length. Means what does it mean? Object and image, they are same size. So it is real, inverted, same size as that of the object. Alright, that's why this case is very important. Alright, you have to remember it. When an object is kept at a distance 2F from the convex lens, then a same size, real, inverted image is produced. Only when you are keeping it at a distance of 2F. Next is object is placed between F and 2F. So again, repeat the same. Draw the principal axis. Draw the vertical line. Take 3 line length up and down. Complete the lens. Then at a distance 3 cm mark F from the point C. Then at a 6 cm distance mark 2F. Do the same on both sides. Then draw the object AB as I have drawn between F and 2F. Alright. Then from the point A, take a line parallel to the principal axis. After diffraction passing through the focus, then take a ray passing through the optical center which is moving undeviated. Then you will observe both these rays are meeting at one point. Name it as A dash. From the point A dash, drop a perpendicular and name it as A dash B dash. Alright. So A dash B dash is the image of AB. So look at the image A dash B dash. This is the point 2F. It is beyond 2F. So what is the position of image? Position of image is beyond 2F. What is the nature of the image? The rays are actually meeting. So real, inverted, upside down. Okay. And you see here, the image is bigger than object. So we say it magnified. We use this term. Magnified means what? It is bigger than that of the object. So when an object is kept in between F and 2F, then image is formed beyond 2F and real, inverted and magnified. Next case is object is at F. Alright, so in this one, what you will do, you draw the principal axis, draw the vertical line, 3 lines up, 3 lines down, draw the lens, mark optical center, then from the optical center at a distance of 3 centimeter, mark the point F only on both sides. In this case, 2F you don't have to mark, alright. Then, where to draw the object at the point F. Then, from the point A, you take a ray parallel to principal axis after diffraction passing through focus on the opposite side. Then take another ray passing through optical center which is moving undeviated. Alright. Now look at these two rays. These two rays, they are parallel to each other. Alright. So where they will meet? They will meet at infinity. What does it mean? What is the position of image? Position of image is at infinity. Alright. Then what is the nature of image? Real, inverted and highly magnified. What is the nature of the image? Real, inverted and highly magnified. Alright. So when the object is at F, then image is formed at infinity and highly magnified image is formed. Next is object is between optical center and focus. So here also for this diagram also, first draw the principal axis, draw the vertical line, 3 lines up, 3 lines down, then draw the lens, then mark the point F on both sides from C at a distance of 3 centimeter each. Alright, then draw the object AB. Alright, where I have drawn the object between C and F. Then take a ray, here you follow how I am drawing the diagram. Take a ray parallel to from the point A parallel to the principal axis till the midline drawn, and then what you will do, this is the most important thing. You see here this point and F, when you will join the point F and this point, when you will join, then do this, holding the scale, you extend in the backward direction by dotted line and in the forward direction by solid line. You have understood what I said? Then take a ray passing through the optical center. So what you will do, you will join AC. Hold your scale so that you can join AC. But when you will join AC, then you see what I am doing. In the forward direction, you extend it by solid line. But in the backward direction, you extend it by dotted line. Alright? Understood what I said? So here what is happening, you see the two rays, they are not, if you consider the refracted rays in the forward direction, they are not at all meeting. They will never meet. Why? They are the diverging beam of rays. So if you extend them in the backward direction, they appear to meet at this point. So name it as A dash. So as they appear to meet, so what kind of image will be produced? It will be a virtual image. That's why draw a dotted perpendicular on the principal axis. Name it as A dash, B dash. Alright. So here, what is the position of image? Position of image is beyond F on the same side as that of the object. Means object and image, they are on the same side of the lens. Then what is the nature of the image? You see this is a virtual image. So virtual means it is an erect image and it is magnified. Alright. So what kind of image is produced? Virtual, erect and magnified. Clear? So if you consider now the image formation by a convex lens, all the cases together. Alright, two important points I am saying here. What I am saying, image formation by the convex lens together, considering all the cases together. What we have observed, that in every cases real image is produced, only in one case virtual image is produced. Alright, when virtual image is produced, when object is between optical center and focus. And what kind of virtual image? Magnified virtual image is produced. So what is the point? You must note it down by putting asterisk. Convex lens always produces real image except when the object is placed between C and F. Alright, then you write when the object is placed between C and F, virtual and magnified image is produced. Alright, so what is the first point? By putting asterisk we will write convex lens produces real image except when the object is placed between C and F. Then next point, putting another asterisk right down, when object is between C and F, virtual magnified, underline the term magnified, virtual magnified image is produced. Alright, then the third point, understand it. Just try to remember, when we have kept the object at infinity, then image was highly diminished point. Then we have kept the object beyond 2f. Then what kind of image? Diminished. Then you have kept the object at 2f. What kind of image? Same size. Then you have kept the object between f and 2f. What kind of image? Magnified. Isn't it? So you see, if you bring an object near the convex lens, then what happened to the image size? Image size increases. Alright. So the third point, you write it down, when an object is brought from infinity to a convex lens, near to a convex lens, then image size increases. Clear to everybody what I said? So these are all about the image formation by a convex. Next is image formation by a concave lens. Alright. So again the first case, object is at infinity. So here how you draw the diagram? First you draw the principal axis. Then you take 3 line up, 3 line down, and then join it. Draw the concave lens. And then you just mark the optical center. This vertical line and the principal axis meeting at one point, that is the optical center. Then for concave lens diagram, drawing is easier than the convex lens. Only you mark focus at any distance. So better you take a 3 cm distance and mark the focus on one side only, on the side of the object. Alright. So you see, when object is at infinity, then the rays coming, they are parallel to each other, isn't it? Parallel beam of rays generally comes from an object which is at infinity. So here, it may happen the parallel rays which are falling on the concave lens, they are parallel to the principal axis. So you see how we will draw the diagram. You will extend the rays till this middle line, then mark F and join this point and F in such a manner that in front of the lens you draw a solid line, but behind the lens draw a dotted line. Now same thing you do for the down one also, means join this point with the focus and extend it in such a manner, forward direction solid line and backward direction dotted line. So here you see the rays appear to diverge from the focus. So where the image will be produced? At F. Okay, where the image is produced, position of the image is at focus. Alright, and what kind of image they appear to meet? So it is virtual and diminished. Why I have not written erect? Because it is a point object, so does not matter. Erect or inverted, actually it should be erect. So you may drop the term virtual and diminished. Then second case, that object is at infinity, the parallel beam of rays coming, but they are not parallel to the, here you see the two parallel rays, how you will take? You take one ray passing through the optical center as I have drawn. Okay, then you take another ray. Clear? Now in this case, how we will draw the diagram easily? At the point F, you draw a dotted line till it meet the ray passing through the optical center. Then name it as point A. Is that clear? And then you join this point A and this one, this line, and extend. Alright. So you see these two rays are diverging beam of rays, and when you are extending them back, it is meeting at this point A. So what is the position of the image? Position of the image is at the focal plane, because you see it is not at the focus. It is on the plane passing through focus and perpendicular to the principal axis. So what is the name of that plane? Focal plane. So what is the position of the image? At focal plane. And what is the nature of image? Virtual and diminished. Alright? Virtual and diminished. Sorry, here you must write it highly diminished. highly diminished because it is a point object, and in this case as it is not point, so you must write it as virtual and diminished. So when the object is at infinity, where the image is formed either at focus or at the focal plane. Next is object is beyond f. So as I already said, what you will draw? Draw the vertical line, draw the principal axis, draw the vertical line, 3 lines up, 3 lines down, then draw the concave lines, mark C and F. Only F, so F you can just mark anywhere, and you can take 3 centimeter distance also. Then where is the object AB? Beyond F. Alright. Then how to draw the diagram? Again you take a ray parallel to the principal axis. So you see, you draw it till this point. Then after diffraction, how it will move? It will appear to pass from the focus. So join this point and the focus in such a manner that in front of the lens it is a solid line and behind the lens it is a dotted line. Alright, and give the arrow. Then take another ray passing through the optical center from the point A, means simply join A and C in the forward direction. Then you see these two refracted rays, they appear to meet at this point A dash. Then from the point A dash, drop a dotted perpendicular and name it as B dash. A dash, B dash, draw the perpendicular on the principal axis. So A dash, B dash is the image of AB. So what is the position of image? Between C and F on the same side as that of the object. On the same side as that of the object. Alright. Next is, what is the nature of image? Look at it. Virtual and diminished. Alright. So remember that virtual and diminished. Clear? So you see, if you take the object anywhere beyond F, then what will happen? Always the image will be formed in between C and F. Clear? Because you see, this line parallel to the principal axis, always it will pass through focus, and the ray passing through optical center, they will meet always in between F and C. Alright, so this is the speciality of the concave lens. Wherever be the object, always where the image will be produced between C and F. Alright, means if you keep the object beyond F anywhere, then where the image will be produced between C and F, and virtual, erect and diminished. I forgot to write erect. Please you write down. Virtual, erect and diminished image will. Next is, you have kept the object at F. Then you see, again you will just in the same manner, you will draw the principal axis, draw the vertical line, 3 lines up and down, then concave lens, mark F. Now where you will draw the object AB at F. Then take a ray parallel to the principal axis. Then after diffraction, it will pass through focus, appear to pass through focus. And take another ray passing through the optical center. Both the rays are meeting at the point A dash. Drop a perpendicular dotted on the principal axis. Name it as A dash, B dash. So what is the image? A dash, B dash. Alright. Now in this case, you should do it. You measure the length B dash F by your scale and measure the length B dash C. You will observe that B dash F and C B dash, they are equal. What does it mean? B dash is the midpoint of CF. Clear? So this is the very important point, that what is the position of the image at the midpoint of CF. And what is the nature of the image? Virtual, erect and diminished. Alright. So if you consider the image formation by a concave lens, what we have observed, that concave lens always produces virtual, erect and diminished image. Not like convex lens that it can produce the real image. But remember that convex lens produce virtual image, but convex lens produces virtual and magnified image. But concave lens always produces virtual and diminished image. This is a very important point and you are supposed to remember this, that concave lens produces virtual diminished, whereas convex lens produces virtual magnified image. Thank you, children.